everyone. Hope all of you are having a great build so far. I'm Sri Chantala from the Cosmos DB team, and it's my absolute pleasure to welcome you to today's session. If you've had a chance to attend yesterday's keynote, you must have heard our exciting announcement on Azure Synapse Link for Cosmos DB. And I'm sure all of you are curious to learn more. So with us today, we have Ramnandan Krishnamurthy, a very passionate member of our Cosmos DB product team, to dive into a little bit more details on Synapse Link. So before we get started, a couple of logistics. One of the advantages of Build being virtual this year is we get to make it more interactive. So as Ram presents, please feel free to post your questions into the chat window, and we have our SMEs from both the Cosmos DB and the Synapse team on standby ready to answer. And finally, in the last 10 minutes, I will pick a few interesting questions to go over. With that, over to you, Ram.
Thank you, Sri. Hello, everyone. I'm equally excited to connect with all of you here at Build today to present Azure Synapse Link and explore how you can now build real-time HTAP solutions on top of your operational data in Cosmos DB directly with Synapse Link. And before we get started, let me apologize for my quarantine hair, but I'm sure all of you empathize with me. And I'll be honest, I will be preaching to the choir here if I try to emphasize the growing needs and scale of modern day applications. Over the years, customers have chosen Azure Cosmos DB as the fully managed NoSQL database in the cloud for modern day app development. By providing single-digit millisecond response times for reads and writes and instant and elastic scalability, Cosmos DB guarantees speed at any scale. Business continuity is crucial for our customers, and this is assured with the industry-leading 5 nines of availability and turnkey multi-master global distribution, while also providing enterprise-grade security. App development just couldn't have been more faster and productive, but thanks to the open source API strategy of Cosmos DB, we are super inclusive for every kind of app developer out there. But while app development is only one half of the story, what we've seen is customers almost always want to generate insights over all this rich data that their applications generate. Think customer transaction data or IoT sensor data coming from oil wells. Pretty much across every single industry vertical, customers are now adopting this data-driven culture. And at the heart of this culture is the need to be able to run analytics over the operational data in near real time and at scale in order to unlock new business opportunities and also optimize existing business processes. And for this, traditionally there has existed two solutions. One, you can run analytics directly on top of your operational database. But the challenges here are that operational databases have traditionally been optimized for transactional reads and writes and operational queries, which are very different from analytical queries, which can be resource intensive. So while it is possible that you can run analytics over your operational database when you have not that much volume of data, as the volume of data in your database grows, the performance of typical analytical queries will quickly start degrading. But worse, they will also affect the performance of your mission critical transactional workloads. And this is something which our customers are never okay with, which is why customers resort to separating their analytical and operational systems in their data platforms. But this would mean that data engineers periodically set up pipelines to periodically move data from Cosmos DB into a separate data lake. And then they have to operationalize, monitor, and manage these pipelines continually over time. And in addition to setting up these pipelines, they also have to now choose and manage the data format in the analytical layer. And for example, we have a lot of columnar data formats which are optimized for analytics. And finally, they also have to repeatedly keep tabs on the organization of data in the analytical layer in order to keep it optimized for the performance of the analytical queries. So you see, only after all of this that customers can actually generate insights over this data. For example, typically using Apache Spark to transform and enrich the data, and then serve the data with SQL. But as you can see, although you can run analytics over this data, and it is possible, you are running analytics over not the latest state of your operational data, but stale data. And you see, this is, so you really are not, it's after, you're getting after the fact insights, which is why we're now super excited to announce and bring to you Azure Synapse Link for Cosmos DB. And this is the first cloud native HTAP capability where you can now run analytics over your operational data in near real time and at scale with no performance impact on your transactional workloads and no ETL required. This is a game changer because we have now broken down the silos between your operational and analytical systems, which has existed for decades. And the magic here is that we have enabled that with a single click. So you must now be wondering, what is powering this Synapse Link and all this magic behind it, right? So let me unwrap this for you. So traditionally, operational data stored in Cosmos DB is internally stored in a row-oriented transactional store. Now, this transactional store is optimized for transactional reads and writes as well as operational queries. But as you remember, as I had mentioned earlier, the analytical queries requirements are very different from the typical transactional workloads, which is why, along with Synapse Link, we're now introducing a fully managed analytical store natively within Cosmos DB containers. Now, this analytical store is a fully isolated column store, which is optimized for analytical queries over large volumes of operational data. And so any new inserts, updates, deletes coming to your operational data in Cosmos DB is automatically synchronized from the transactional store into the analytical store in near real time, within minutes. Further, this capability called auto sync ensures that there is no performance impact on your transactional store. And in the world of Cosmos DB, that translates to the fact that there is no RUs consumed from the RUs you provision on your Cosmos DB containers. So you see how we have now made it super easy, and we manage the solution for you, where we are making sure that the operational data you bring to Cosmos DB is automatically made available in an analytical friendly format. And further, with Synapse Link, we now with a single click connect Azure Synapse Analytics and all its power to the data and analytical store, which means you can now run Apache Spark and T-SQL queries interchangeably on your data in the analytical store. This is game changing because you can now build ML models, build big data analytics pipelines, and responsive BI dashboards directly on top of your data in Cosmos DB without any data transformations, without any ETL, without any performance impact. This is why this is the biggest announcement here at Build, and we are super excited to bring this to you. So let's put this, make this more real. Let's take a look at a demo. So for this demo, we're going to take a particular scenario, which is a typical retailer who wants to build their modern age supply chain management platform on Azure Cosmos DB. Now, this supply chain management platform wants to track the retail operations across thousands of store locations for this retailer, as well as track the inventory across hundreds of product SKUs which this retailer sells. Now, in particular, we're going to look at Synapse Link and what end-to-end scenarios that this makes seamless right now. So two things which we're going to look at. One is how you can build responsive business intelligence reports over all of this data in your supply chain management platform, and also how you can build end-to-end sales forecasting pipelines. So let's dive right into the demo with a prayer to the demo gods. So this is the Cosmos DB Data Explorer, which I'm sure all of you must be super aware of. Now, typically, a supply chain management platform would involve a lot of data entities, and it would be much more complex. But for this demo, we're going to make it simpler and more scoped. So here you can see that I have a few different Cosmos DB containers. A product container, which stores data about the product SKUs, a retail sales container, which is more of the fact data, which is the real-time sales data coming in, And then also have a store demographics container, which is storing information and metadata about what store it is and some details around it. The retail sales container is something which is the fact data, and hence it's more interesting. So let's take a look here. So as I had mentioned in the preface, this container gets real-time data coming in here right now, and it's storing what is the price of a particular product and what quantity was sold in a particular store. And let's put this to use in Synapse Link. Now, remember I had said that Synapse Link was this magical single-click experience. Let's see what that translates to. Now, in order to enable Synapse Link in your experiences, when you create a Cosmos DB container, all you have to do is you can now see that there is an analytical store toggle switch. Now, all you have to do is once you enable this analytical store during your container creation, all new data, inserts, updates, deletes coming into your Cosmos DB are automatically managed and synchronized by us into an analytical friendly format in the analytical store. And then you can then directly run queries, BI dashboards, ML models, and everything on top of this data and analytical store, which is where Synapse Analytics comes in. And so let me take a swap into the screen of Synapse Analytics. And this is the single pane of glass experience of Azure Synapse Analytics, where you can leverage the deeply integrated power of Apache Spark and Synapse SQL runtimes to explore your data, analyze your data, visualize your data, right? Now, so let's see how easy it is to connect the data I had in my Cosmos DB into Synapse. For this, I'm going to go into the data tab in Synapse. And now let me first point to you that Cosmos DB is now a first-class citizen in Synapse, along with the data in your storage accounts. Now, if I want to link my Cosmos DB database, which had all of the sales data, it's super simple. All I have to do is connect to external data, and then you can see that Cosmos DB shows up here. All you have to do is fill up the Cosmos DB account name and your database, and then boom, it automatically gets linked into your Synapse workspace. And I've already gone ahead and done this. So in my Cosmos DB tab, I can see that there's a Surface Sales DB which is linked in my Synapse workspace. And you can see that the containers, the retail sales container, the store demographics container, and the product container are all reflected here. And what can I do here? We have simplified the experience for you to start running analytics so that you really don't have to, anyone can leverage the power of Synapse Analytics to run analytics directly over your data in Cosmos DB. So to get started, we have these simple, easy to use gestures where you can run Spark notebooks. So you see there are a lot of different scenarios which you can enable with a single click, like loading the data from Cosmos DB into a Spark data frame, writing the data into from a Spark data frame into Cosmos DB, creating Spark tables, doing streaming. And similarly, you can, using the power of Synapse SQL serverless, you can create views, explore your data, and much more. This is really the power and simplicity which we bring with Synapse Link. And so let me first go to the scenario which we spoke about, which was I want to build a responsive BI dashboard over this data in Cosmos DB directly. For that, I am going to go over into the Develop tab. And here for the demo, I've already pre-created a SQL script. And in this SQL script, I want to direct your attention to a few things. First, you can see that I'm creating a SQL database called Retail Cosmos DB over my data in my Cosmos DB containers. The reason I'm doing this is so that I can then build SQL views over my Cosmos DB data. So you can see here that I'm creating a store demographics view. And while I'll show you that, let me just run this query. As you can see, this is leveraging the power of SQL on demand or SQL serverless. And so I'm first running this query, but I'm quickly show you that here I'm creating a view over each of the 3 different Cosmos DB containers. And you can do complex T-SQL queries right here. And boom, this is how, with the serverless technology of SQL in Synapse, you can explore your data. So I have run a query over my Cosmos DB data, and note this is T-SQL over NoSQL data. That is right there is something which has been unimaginable in the past. And so now I have created these views. Where can I see these SQL views which I have created? So you can go back into the data tab. And now if you go to workspace, you can see here that there are a bunch of different databases. So first, let's look at the SQL on-demand database. So this is the Cosmos DB database, which I had created above. And now if I go to views, I can see each of the 3 different views which I had created over my Cosmos DB containers. Note, we are not staging the data in Synapse at all. What we're doing is just creating views over the data such that when you run a query, we push down the queries to the actual storage layer in the Cosmos DB analytical store to run. So that is how you're actually able to run analytics over the latest state of data. There is no staging or stale data being analyzed here. So now once I have built these SQL views over my Cosmos DB containers, leveraging the native integration of Power BI in Synapse, I can very easily take this SQL views and make them, they're automatically available as Power BI datasets in my Synapse workspace, and I can go about and build dashboards. For that, let me go here. So you can go to the Power BI and Develop tab. And again, here, for the sake of demo, I have pre-created this responsive dashboard. But you can see the power here, right? The SQL views which I created get manifested as tables in my Power BI data set here. So you can see that all of the columns are also filled, and I can now drag drop, build these responsive dashboards. Here, for instance, I'm trying to analyze what's the revenue of different product SKUs week on week. And I can create more aggregate views, tiles as well. You know, this is the power of Power BI, and I'm sure all of you know about that. So finally, once I'm trying to explore my data, I can finally save this Power BI report and make it immediately available to my business consumers. This is how, with a single pane of glass, you're able to analyze, report over your data, the live data, and then publish this to your business consumers. This is a great power. And next, let's switch our attention to the ML scenario, which we were talking about. For that, I'm going to use the power of Apache Spark. And in that, let me show you this particular notebook I have here, which is this notebook here. Before we get into the notebook, I'd like to point you to this here, which is you can attach your notebooks to Apache Spark pools, which you can manage here. So in Apache Spark pools, you have the power of auto scale. And you have all of the power of Spark available to you here. And when you're writing notebooks against Spark, you can choose different languages. You have Python, Scala, C#, and also native Spark SQL. So let's switch right into how I can build this end-to-end pipeline, right? So here, in order to build this forecasting model, my goal is to be able to forecast the demand in stores in the upcoming weeks. And this is needed so that me as a retailer can optimize my business processes, right? So let's see how Synapse Link makes this super simple. So first, Synapse Link allows you to seamlessly create Spark tables. Like how you created SQL tables, you can create Spark tables over your data in Cosmos DB in the analytical store. Again, here I'm creating a Synapse Spark table, and you can see how it's super simple for you to be able to create these Spark tables over each of the different Cosmos DB containers. No complex ETL, easy views which are created. And again, similar to how you could go see your SQL on-demand tables, you can also see your Spark tables here. So you can see I have a Spark database, and here I can see that I have all of my 3 containers represented as Spark tables. Now, why did I have to create these Spark tables? It is because I can then leverage the power of Spark SQL to join this data across all of these tables and perform complex aggregations. And this is valuable because a typical operational database is not designed for you to do joins across different containers, across databases, right? That's more of an analytical scenario, and that gets powered with Synapse Link. Now, this is needed so that I can aggregate and enrich my data across containers and create a data set which my data scientist can then go and train a model on. And here, to showcase the power of the native ML experience within Synapse, I'm going to show you the power of Azure Machine Learning's AutoML to build this end-to-end pipeline. The reason AutoML is great here because not everyone has the same level of data science expertise, and hence AutoML is basically democratizing machine learning for every single person out there to get insights out of their data. And here you typically go through the traditional pre-processing steps in an ML pipeline, like engineering your features, splitting your train and test data sets, and then I'll direct your attention to the actual training of the model, right? And as I had said, AutoML leverages model parallelism, where you can say, let AutoML, you just define the task to say, here is my data set, training data set, here is the task I need to perform, forecasting, and you let AutoML test out multiple machine learning algorithms and then pick the best model for you. So in this case, for instance, I see that AutoML tried out 30 plus different models and then chose, and then you can see that it's also scored a target metric against this, which is how it then picks up the best model for this particular training data set. And in this case, you see the random forest regressor was the best ML model for this data set. And then you can further validate how good this model is by testing it against this separate test data set I had, right? And that's what I'm going to be doing here, which is I'm going to visualize how good this model is. So here is that, where I have applied and scored all of the test data I had through this ML model, which was just trained. And just to make it a little clearer, the green dots represent the actual truth of what the demand was, and then the predicted values is what the ML model predicts. And as you can see, the ML model is quite good here, so I'm happy. And now I want to take this model and operationalize this, which is where the Azure Machine Learning's ML Ops pipelines allow you to deploy this model to where it is needed in real time, which is in the application layer. So you can then score data as they come into your operational database by having your ML model deployed right where your data is. And as you can then now see, take both the responsive BI dashboard scenario and the end-to-end ML scenario, you can see now how with Synapse Link, you can achieve these real-time HTAP solutions over your data in Cosmos DB directly. I'm sure all of you are super excited as much as I am here. And if you want to get your hands dirty, we have more end-to-end scenario-based samples of Synapse Link, including the one I just showed at this AKMS link. And we have much more rich documentation as well, which I do recommend all of you to go take a look at. With that, Shri, it's back over to you.
Thank you so much, Ram. That's certainly very exciting. So I think even the audience thinks the same. So we've seen a lot of reactions and a lot of likes come your way. But unfortunately, we have a little bit of a technical glitch where it looks like the chat box is locked and hence people couldn't post their questions. But not to worry, I'm going to take a stab at it and try and ask you a few commonly asked questions that I commonly see customers ask. So let's get started. So Ram, you mentioned about the real-time synchronization from the transactional store to the analytical store. So what exactly do you mean when you say near real-time?
Okay. So let me emphasize that again. So with the auto sync capability of Synapse Link within the Cosmos DB analytical store, any new inserts, updates, and deletes to your operational data are automatically synchronized from the transactional store into the analytical store. And this happens in near real time within minutes, right? Now, the exact latency depends on the rate of data ingestion, but it is typically 2 minutes and always less than 5 minutes. But you see the value here, right? Which is instead of periodically setting up these pipelines, which were moving data at the frequency of hours or days, your data is immediately available. And once your data is available in the analytical store, you can directly run Spark and SQL queries over this data.
Makes sense. That's awesome. So now you're saying that from previously where our customers needed a few hours to a day, so you can do it in a couple of minutes. That's pretty cool. So another question that most customers have is, do you need to allocate RUs separately for your analytical store?
Great question. No, the answer is no. Now, RUs as a concept in Cosmos DB is for your transactional workloads and hence for the transactional store. the analytical store itself has no concept of RUs and instead follows a consumption-based billing model. So essentially it translates to what's the volume, GB of data you're retaining in the analytical store every month, as well as the reads and writes operations against the analytical store. Now, the autosync is what causes the write operations against the analytical store, and then any analytical queries you run from Spark or SQL generate the actual read operations. Now, both you can find more richer documentation about the exact pricing in our pricing documentation, Sri.
Sounds good, Ram. So one question I think that's probably on everyone's minds is this is a great capability. So will Synapse Link be extended to other Azure databases as well?
Absolutely. And I'm going to be talking on behalf of Azure Data here. The strategy is to bring the power of Synapse Link to the family of operational databases we have in Azure: SQL DB, Postgres, MariaDB, MySQL, all of it. Cosmos DB is the pioneer here, where we have innovated and brought this to your hands first, and we are looking to get as much feedback so that we can incorporate that while we extend this support to our other operational databases.
That makes sense. So one other question, Ram. So you kind of showed us how we can pull out the data from the Cosmos DB analytical store into Synapse Workspace. So once you have that data there, is there a way for our customers to join this data with, say, their other data sources?
Yes, and that's very much needed because as I showed, you can create Spark and SQL tables over your Cosmos DB data, right? So you can leverage the power of Apache Spark and SQL serverless. But while you create that, you can also create views and tables over your data and storage accounts like Blob, ADLS, and then join this data. Like how I showed joins across Cosmos DB containers, you can also do joins across data in ADLS and Cosmos DB and enrich this data. And the reason why you need to enrich this data is typically if you want to do BI and ML pipelines, you will need to enrich this data.
Makes sense. So before we wrap up, last two questions. So you kind of mentioned that how the auto synchronization capability of analytical store takes care of like transforming the data from a row format to a column format. So is there anything specific about this columnar format Cosmos DB sort of transforms the data into, and how does it compare to other columnar formats, Ram?
Great question. I was hoping you would ask that because this is a very important point to note, right? There are a lot of columnar formats out there, but pretty much all of them are optimized for storing immutable data, which means the data is not frequently changing. But in the context of HTAP, when we started off building this, how do we achieve HTAP, right? In cloud native HTAP, we needed a columnar format which allows your data to be frequently updated. So because in an operational database, that's a fundamental thing, right? You can get very frequent updates, deletes, replaces. And so this needs to be represented in the columnar format natively so that you can run analytics over this fast changing operational data, which is why we've built on top of existing technologies, but come up with a very native novel solution for how we store the data in the columnar store.
Awesome. So last question before we wrap up, Ram, you mentioned that Cosmos DB supports multiple APIs. So is this capability available across all the APIs for Cosmos DB?
Yes, our goal is to get it across the whole API stack. Right now, we are doing a public preview for the SQL API and a gated preview for Mongo and Cassandra, but we are very soon bringing it across all our APIs.
Awesome. Thank you so much, Ram. That was a great session, and I hope the audience enjoyed it as well. So folks, that's it from us for today, and hope all of you enjoyed it. So please do attend our other sessions as well. So on the slide are our upcoming Cosmos DB and Synapse Analytics sessions. So please go ahead and attend it. And also feel free to, if you loved our session, please tweet and tweet at us, and also follow us on Twitter and YouTube. Thank you, everyone.
And do go ahead and give the session feedback as well. We're looking forward to seeing that.
Yeah. Thanks, everyone.